For this video, let's try to prove this relationship between a trigonometric function of complex numbers and a hyperbolic function of complex number. We have here, we are going to show that the sine, okay, of iz is equal to I sine, a hyperbolic sine of z, okay? So we're going to show that to be true. To start with, let's not forget the equivalent form of sine z and its hyperbolic function, because later on we're going to use them in our manipulation. Our sine z has equivalent form e to the power of iz minus e to the power of negative iz, that's negative iz over 2i. As for the hyperbolic function, it's just simply e to the power of z minus e to the power of negative z all over 2. Okay? So take note, it would be equivalent, or the form is I sine a hyperbolic function sine of z. That would mean there is a factor of I here from, that would be our target, from to starting with the given identity on our left hand side. Okay, we're going to start with the sine I z. Okay, what does this mean? Take note that the angle here is z. Now we're going to change it to iz. So it would mean that all the z's here, okay, will be changed to iz for that matter. So what will happen here is this. It will be equivalent to e to the power of I. Our z becomes iz minus e to the power of negative I. Our z is also iz. Okay, all over 2i. These were z's earlier when this angle is also z. Okay, so please take note of that. Again, our goal is to arrive at this point with a factor of I. Hopefully, we could arrive at that to show this identity to be true. So what will happen next here is, of course, you have I times I. It will become e to the power of I squared z minus e to the power of negative I squared z all over 2i. Okay, that's the denominator. Allow me to continue here and take note that we know that I is actually equivalent to the square root of negative 1. So I squared is actually negative 1. That is true for this form here and here as well. So what will happen is that they will become negative. So you will have here the form e to the power of negative z, or negative 1z, minus e to the power of the negative of negative. So you have positive 1z all over still 2i. Now look at this and look at the equivalent form, our target. We already have the similar forms of our numerator. It's just that they are rearranged differently. Okay, it should be e to the power of positive z minus e to the power of negative z. And since that is our goal, let us rearrange our numerator. So you will have here negative e to the power of z plus e to the power of negative z all over 2i. Again, take note, our goal is this, minus. So what if we are going to factor here negative 1 e to the power of z minus now e to the power of negative z all over 2i. Okay, now what is negative 1? Okay, this negative 1, as mentioned, is actually I squared. So if we can actually change it to I squared e to the power of z minus e to the power of negative z over 2i. We're doing that because we have another I here in denominator. So when we try to factor that, we'll have here I times e to the power of z minus e to the power of negative z all over, that's all over 2. Okay, so hopefully that's clear. We are able to factor or cancel that, or yes, because we have same factors of I, and we have 2 i's on our numerator, so I squared, so we only have I remaining. Now, what is this equivalent to? This form here. That's actually our hyperbolic function indicated here. Okay, this is our goal. Make sure that it has okay, here a factor of I, and our I is already here with this being hyperbolic function. So we have shown here that the sine iz is equivalent to a factor of I times this equivalent form, which is just the hyperbolic function of z. We have shown this to be true, and that means this relationship between trigonometric function for sine iz, and we have here the hyperbolic function for z with a factor of I, are equivalent to one another. Thank you very much for watching.